Welcome to part 2 of Lab 3. In this lab, we're going to be analyzing what is essentially a voltage divider, except now it has complex impedances. So to start, this is the circuit that we will be using. So here, right here, these cords are the input. They're coming from their function generator. I'll show you that in a little bit. But it's going from the function generator through a 2 kilo ohm resistor. Then it's going, if you see, it's actually going through this is called a decade resistance box, and I'll get to that in a minute. It's going from the decade resistor box to three capacitors that are in parallel. These are directional. So actually, if you can see on here, so they're polarized, so they have to be facing the correct way. So they all are facing the same way. Then it's going, this is actually an extra jumper wire, but we're actually going to get to why I have that there near the end when I'm measuring current, and it's going to ground. And again, this entire long bus is grounded, so it's grounded, and this, what's from the input, is going to the ground. I also left off these wires right here, this green and this yellow wire. So this yellow wire and green wire are connected to BNC cables that are going to channel 2 of the oscilloscope. So we are essentially measuring from this point through the resistor, through the capacitors to ground. So we're measuring over that. So how this is a voltage divider is this is essentially your impedance for Z1, right? And whatever your impedance is from this and this is your Z2, because you're measuring over that. So what we're going to do is we're actually going to play around for a little bit with this decade resistance box. So this decade resistance box can actually, the advantage of it is it can have the resistance changed. So this reads 500 ohms, right? So if I were to increase this by twisting these little knobs, you can spin them. Now this is 700 ohms. I can change it to 10,700 ohms, and so on. So this is just a really cool way to change the resistance. Instead of actually having resistors, you can actually set what the resistance actually should be, and you have a much more easier way than doing it than just putting a bunch of resistors in parallel in series to kind of create your resistor combination. So the first thing we're going to do is actually we're going to need that set to 2 kilo ohms. So we're going to have that set to 2 kilo ohms right now. All right, so let's take a look at what's going on the function generator and oscilloscope. I apologize, but we're not going to be able to fit all of them into one screen, so we're going to have to kind of jump in between those as needed. All right, so this is the oscilloscope and function generator that I was mentioning before. So on the function generator, we have a splitter. One end of the splitter is going to channel 1 of the oscilloscope, so that channel 1 of the oscilloscope is essentially showing your input signal. And then the other end of the splitter is going as the input to the circuit. So when I mentioned before that it was over the entire circuit, that's coming from the function generator. So channel 2 of the oscilloscope is measuring over those components that I mentioned, which were the decade resistance box and the 3 capacitors in parallel. So channel 2 is measuring over that. And so we're going to have 2 different waveforms on the screen that we can see that. So we can see that we're outputting roughly 50 ohms. I mean 50 hertz. Let me adjust that a little bit more. Actually, I suppose I should use the fine knob because that's what it is. All right, so we're outputting roughly 50 hertz of a sine wave. That button's pushed in, and we can adjust this amplitude knob to get the right reading. We want 6 volts peak to peak. So in order to do that, let's actually zoom in on the oscilloscope. Just know that in order for us to be switching those values, we're twisting this knob right here. All right, so here's a bit of a close-up more on the oscilloscope, so you can kind of see what's going on. So in order to get these measurements, the easiest way to do it is hit the measure button. This is already set up for us, but obviously if we wanted to hit the button, wanted to change these values, we could hit the button next to it and cycle through. So if we wanted channel 1 max to be something else, we can sit through here and cycle through so it actually measures something else, and we can actually change it from channel 1 to channel 2. So, but anyways, it's already set up for us. So the channel 1 is at peak to the channel 1 peak to peak is already 6 volts. If it wasn't, we could kind of twist the amplitude knob that I was just mentioning on the function generator to adjust that. The channel 2 peak to peak value is roughly 3.36. But you will note that the channel 2 phase, if we hit the button next to that, first of all, we can see that it's actually the phase. Let me see if I can focus that in. Yeah, so if you can barely read there, that actually says channel 1. So it's the phase in regards to channel 1. So it's the phase angle of channel 2 with respect to channel 1. So, but the thing is there's actually a question mark next to it. So that actually means that the oscilloscope is not reading a correct value, or it's just estimating. It's not sure if it has the right value. So in order to do that, let's go ahead and hit back. We can actually adjust this scale knob and kind of increase the scale so that these two are roughly the same size on the same scale. And as you can see, it's still jumping around a little bit, but it does know what the phase is. So it's roughly negative 14, jumping around a little bit. I think that's just because of our connections. So anyway, so what we're going to do, this is obviously with the decade resistance box at 2K, and obviously this is measuring at least the channel 2 over the 2K ohm decade resistance box and the 3 capacitors in parallel. So what I'm going to do is I'm going to actually increase the value of that decade resistance box. So I can't show you it at the same time because there's no real way to get both in the screen. But what I'm going to just do is I'm going to tell you what I'm actually doing. So I'm going to increase it from 2 kilo ohms to 3 kilo ohms. You can see what's happening there. I'm going to increase it to 4 kilo ohms. Now I'm going to actually increase it to 14 kilo ohms. And I can keep going up. So this is 24 kilo ohms. And so we note what's changing, obviously. Let me go back with regards to the channel 1 peak to peak and channel 2 peak to peak and the phase between those. So I'm going all the way back down, going back down to 3000 K and 2000 kilo ohms, right? And so now let's go smaller. So what I'm going to do is I'm going to go down to 1 kilo ohm. I'm going to go to, let's say, 900 ohms. All right, so and now I'm going to go down to 700 ohms, right? And I'm going to go down to 500 ohms, 300 ohms, 100 ohms, and we'll take it all the way down to 50 ohms. All right, so you can kind of see what's going on there. Again, this is with the function generator is inputting 50 hertz and roughly 6 volts peak to peak. It's slightly changed a little, so let me increase it a little bit. But anyway, so in your lab, it asks you qualitatively what happens when you increase the resistance and decrease the resistance of your decade resistance box. So that is what we just did. So your job is going to be to answer that in terms of the peak to peak voltage and the phase change of the output voltage with respect to channel 1. So you should be able to see those values there as I change through them. So you'll be good to answer that question. Now, after you answer that question, we're going to set the decade resistance box to 500, and we're going to change, and we're going to again note the peak to peak of channel 1 and channel 2, and the phase of channel 2 with respect to channel 1. You should probably write those down. I believe it asks for it in part 2 of the lab, so you should write those down. And this is again at 50 hertz, right? So what we're going to do is we're actually going to increase the frequency. Actually, let's actually display that. So the channel 1 frequency is roughly 50 hertz, right? So let's increase the frequency of channel 1 to roughly 500 hertz. All right, it gets kind of messy. There's a question mark, all sorts of stuff. So let's hit the auto set button see if that helps. That's the first thing we want to do if something's wrong, is hit the auto set button. Go back and hit the measure button, and looks pretty good. So again, so we can see the frequency is 500 hertz roughly. The phase is now roughly negative 9.38 degrees. The peak to peak is 1.3, and your input peak to peak is 6. So you're outputting 1.3 volts peak to peak with a phase angle change basically of that with respect to the input of roughly -9. It's jumping around a little bit, but you should generally take like a middle value on that. All right, so now that we have those values, basically, so I told you to record it at 50 hertz. You can obviously record it also at 500 hertz, and you should be able to calculate what the theoretical values should be. So you should be able to calculate the theoretical phase angle change with the theoretical peak to peak, the theoretical peak to peak and the theoretical phase angle of channel 2 with respect to channel 1. You should be able to calculate that. It's just a simple voltage divider. Again, so Z1 is just a 1 resistor, and it is a 2 kilo ohm resistor. Z2 is basically a decade resistance box. It's set to 500 ohms. With that, it is going into the to 3 capacitors. Each capacitor is 1 microfarad, and then it's going to ground. Yeah, so just to reiterate, basically, this is your 2 kilo ohm resistor. This would be Z1. It is then you're measuring over Z2, which is from here to here. We set the decade resistance box to 500 ohms, so you can get that reading, 500 ohms, and it's going through 3 capacitors that are 1 microfarad at each. I realized earlier I may have misspoken and just called them like just 3, but I'm not sure if I said the value or not, but they are 1 microfarad capacitors, each of them. They're directional, and so together, I mean, obviously they add up to 3 microfarads, but they're each 1 microfarad capacitor. But anyway, so that's a voltage divider. You can calculate what the peak to peak expected for the output is, and the phase angle for the output is with respect to channel the input voltage, channel 1.